Myself, Deekshita. Today I'm going to do a tech talk on data structures. The introduction of graphs, fundamental concepts. Graphs are nonlinear data structure consisting of a set of vertices and a set of edges that connect pairs of vertices. Edges can be directed, indicating a one-way relationship, or undirected, signifying the two-way relationship. Can also have associated weights or costs representing graph adjacency matrix versus adjacency list. Adjacency matrix AV into V matrix when V is the number of vertices and entry A of I of j is 1 if an edge exists between vertex I and vertex j and 0 otherwise. For weighted graph stores the weight. Adjacency list an array of V list where the ith list consists of all vertices adjacent to the vertex I. Each element of the list can also store edge weights. Breadth first search level order transfer. BFS is an algorithm for transferring a searching tree or graph data structures if starts at a design source vertex and explores all of its immediate neighbors at the current depth before moving to the next depth level. F systematically explores the graph layers by layers, expanding the frontier of visited nodes uniformly. A queue data structure is fundamentally used to manage the order of the vertex exploration, ensuring that the vertices at a given depth are proceeded before those at deeper levels. DFS guarantees finding the shortest path in terms of the numbers of edges between the source vertex and any rechargeable target vertex is an unweighted graph. Depth first search DFS. DFS is an algorithm for transferring or searching tree or a graph data structures. It starts at the source vertex and explores as far as possible along each branch before backtracking. This is go deep first strategy constructs with BFS layer by layer approach, prioritizing the exploration of descendant nodes before sibling nodes. A stacked data structures or recursion is typically employed to manage the order of vertex exploration and backtracking. When a dead end is reached, the algorithm backtracks to the most recently visited vertex that still has unvisited neighbors. DFS was BFS. BFS excels at finding the shortest path in the unweighted graph at a suitable full problem requiring the discovery of vertices closer to the source. It explores systematically. DFS is a space efficient for deeply nested graphs and is often preferred for problems involving path existence, cycle detection, or typological sorting. It explores deeply. Weighted graph introduced edge cost and shortest path problems. Weighted graphs are the graphs where each edge has associated numerical value, often referred to as a weight, cost, or distance representing the strength or difficulty of transmitting the edge. Here we have different type of algorithm. This is Dijkstra's algorithm, and then we have Belmont algorithm, and then we have here the same thing, Floyd-Warshall algorithm, and then here is a concept of minimum spanning tree connecting networks efficiently. A spanning tree of an undirected connected graph is a subgraph that is a tree and connects all the vertices together. A minimum spanning tree, MST, is a spanning tree whose sum of edges weights is as small as possible among all possible spanning trees for a given weighted connected undirected graph. MST are crucial in applications such as network designs, cultural analysis, and image segmentation. The problem aims to find the subset of the edges that form a tree including every vertex and has a minimum possible total weight. Here is the Prim's algorithm. Prim's algorithm is a greedy algorithm that finds at a MST of weighted undirected graph. It starts at the arbitrary vertex and grows to the MST one edge at a time. At each step, it adds the cheapest edge that connects a vertex already in the MST to a vertex outside the MXT, preventing circle. Similar to Descartes' algorithm, a mini property Q is commonly used to efficiently select the minimum weight edge connecting the current MST to the external vortex. Its time complexity is typically order of E log V or order of E plus V log V with efficient property Q. Implementations making it effective for dense graph. Here is the crystals algorithm and then the heuristic search information pathfinding with a algorithm are informed search techniques that use problem specific knowledge to guide significantly improving efficient compared to uniformed methods like BFS or DFS. Combines aspects of Descartes' algorithm are greedy best first search. It evaluates nodes using the cost function f of n equals to g of n plus h of n, where g of n is the cost from the start node of node to n, and h of n is the estimated cost from n to the goal node. It guarantees finding the shortest path is a heuristic function h of n is admiscent overestimating the true cost to the goal and consistent. Thank you.